dear students, in this video we will see chapter 2. You see the definition for linear homogeneous recurrence relations with constant coefficients. Okay. Now this equation is called linear homogeneous recurrence relation of degree k with constant coefficients. Okay. Now here we say degree is k. Yes, degree is k. You see in the last term, what is the suffix value of a? That is a n minus k. This is the degree k. Now here, what is this? C1, C2, etc. Ck. All these values are real numbers. All these values are real numbers and not equal to 0. And not equal to 0. Now here clearly we can say that this is the linear homogeneous recurrence relation. Why? You see an minus 1, an minus 2, etc. an minus k having the degree 1. Okay. So this is linear homogeneous equation. Okay. There is no doubt on this. So now see the degree of this equation is k and this is linear and c1, c2, etc. ck are all real numbers and that is not equal to 0. That's it. Now we have the following algorithm for solving of a linear homogeneous recurrence equation of the second order. Okay, of the second order means here degree is 2. Now you see an is equal to c1 an minus 1 plus c2 an minus 2. So this is the degree of the equation. So what is the degree here? 2. So that we are saying that this is second order linear homogeneous recurrence relation. Okay. Now you see how we confirm the linear homogeneous recurrence relation. See here the degree of an minus 1, an minus 2, here 1. So this is linear and homogeneous. And this is the recurrence relation or recurrence equation of the second order. This here we have 2. So that this is the second order linear homogeneous recurrence relation. Okay. Now how to solve this? We have the procedure. Okay. First we have to do, see, number 1. First we have to do means write the characteristic equation of this relation and then we have to solve that characteristic equation to find the roots. Okay. That characteristic equation definitely will give 2 roots. Okay. 2 roots because here degree is 2. Okay. 2 roots. Now we have 2 possibilities. Now see, suppose I get 2 distinct roots. 2 distinct roots that r1 and r2 of the characteristic equation. Then how to write the general solution? That is an is equal to alpha 1 r1n plus alpha 2 r2n. Okay. Why? See, alpha 1 and alpha 2 are constants. Okay, arbitrary constant. R1 and R2 are the roots. Okay, 2 distinct roots. So that this is the general solution of the given second order equation. Okay. Suppose, see, the characteristic equation has a unique root. Suppose having only means 2 roots but the same root repeating. See, r naught is a root but it is repeating 2 times. Okay. So now that is called unique root 2 times. Okay. Then in that situation, in that case, how to write the general solution? How to write the general solution? That is an is equal to alpha 1, alpha 2. These 2 are arbitrary constant. Alpha 1 r naught means that root power n plus alpha 2 n. You see here n. Multiply n and then r naught power n. Understand what I am telling? See here, if roots are different, just you write like this. Suppose we have one root and it is repeating one more time. Okay, one more time. Then how to write the general solution? an is equal to alpha 1. This is a constant. Then multiply r naught power n plus r2 multiply n and then again multiply r naught power n. Because here, see, one root repeating 2 times. So here don't multiply anything, but here you multiply n. Okay. Suppose means I am telling here the example. Suppose here we are dealing with the third order equation. Suppose one root repeating 3 times. Then what you would write here? Just I am writing here. One root repeating 3 times, suppose. Then what you would write here? Alpha 3, the constant. See, this root or not power n. But what you would write here? You would write here n squared. See, because one root repeating 3 times. So that, see here, nothing means no n. Here multiply n in the second term, multiply n square in the third term. Okay. So this is the way how to write when root repeating. Okay, how to write the general solution. That's it. Now, what is the third point? Write equation system for alpha 1, alpha 2 using given initial values a0, a1 and solve it. Okay, that when we solve the question, when we solve the problem, we will understand it simply. Okay, substitute the found values of constants in the general solution. Okay, these are the steps how to solve, how to complete the solution for the given linear homogeneous recurrence equation of second order or third order we can do. Okay, now we will go to see the example. Okay, now you see here, see same situation here also explained. You see solving recurrence solutions. Okay, the solutions of this equation are called as characteristic roots. Yes, let us consider the linear homogeneous recurrence relations of degree 2. You see here degree 2. See an equal to c1 an minus 1 plus c2 an minus 2. Okay, now what this theorem says, suppose we get two distinct roots of this equation. This is the characteristic equation. Okay, this is the given relation, recurrence relation. This is the characteristic equation. When we solve the characteristic equation, suppose we get two distinct roots r1 and r2. How to proceed? Okay, how to proceed to find the general solution. Then the sequence an is a solution of the recurrence relation. See an, this is the relation. Then what is the solution? How to write the solution? an is equal to see alpha 1 r1 power n plus alpha 2 r2 power n. Okay, that's what we have seen here. That's what we have seen here. Okay. Now for n equal to 0, 1, etc., where alpha 1 and alpha 2 are constant. Okay. Now we will see one example for this. Okay. This is the example, but I will explain through another example. Okay. Now you see, solve this equation, this recurrence relation with the initial conditions a0 is equal to 3 and a1 equal to 6. Okay. Now first we will confirm what is the degree of the equation. You see here 2. So this is the degree 2. Okay, which means here this is the second degree recurrence relation. Okay, it is linear. See an here, what is the power 1 here, 1 here. It's linear. Obviously it is linear. Linear homogeneous recurrence relation of second order or second degree. Okay, we can say. Okay, now you see here, to find the roots, what we have tried, we have to write the characteristic equation. You see, that's what here we discussed. See, relation of degree 2. Then we have to find the characteristic roots. Okay, see, we have to write the characteristic equation and then we have to find the roots of the equation. Okay, that is the procedure. Okay, now here we will see in this question. Now you see here, what is the solution? See, what is the given equation? an is equal to an minus 1 plus 6 an minus 2. This is a given equation. Okay, given equation in the question. Okay, now you group all the values in left side. An minus this an minus 1 minus 6 an minus 2 equals 0. Okay, now for homogeneous solution we have to write the characteristic equation first. Okay, everybody, you have to watch this question clearly. Okay, if you understand this, actually we are going to apply the same procedure in all, means in each and every question we are going to apply the same procedure. You understand this and you watch this carefully, then it is easy to understand and do all the questions. Okay, now we are going to write the characteristic equation. What is the characteristic equation? This is the characteristic equation. M squared minus m minus 6 is equal to 0. You can use r or m. Okay, that's your wish. Okay, now you see here how we can find this equation. Okay, now what is the characteristic equation? How to find the characteristic equation? Okay, now first you write the given recurrence relation. Okay, an minus, you group all the values in left side. Okay, so an minus 1 minus 6 an minus 2 equals 0. Okay, now you write here, suppose you have an, then you write r power n. minus here in suffix n minus 1, so you write minus r power n minus 1. Minus 6, here you have n minus 2, you write r power n minus 2 equal to 0. Okay, this is the way how to write the characteristic equation. Okay, then what you do, you divide this entire equation by r power n minus 2. So what will happen? Here r power n minus 2 will be cancelled, so you will get 6. If you divide here r power n minus 2, r power n minus 2, what will happen? You see here r power n cancel. So here in the numerator I have r power minus 1. This r power minus 2 from the denominator it will go numerator. So r power 2 will go. In the numerator I will write r power 2. So r power minus 1, r power 2, which means r will come. Okay, that's here. So here if you divide by r power n minus 2, r power n cancel, so that you can write r power 2 in the numerator. This is the characteristic equation. This is the characteristic equation. This is what we are writing here. You see, this is what we are writing in m. That's your wish. You can use r or m. So that you are writing here m squared. You see m squared minus m minus m. Actually, in the exam you can write this directly. How to write directly? I will explain now. You see here, after grouping the given equation, you see here what is the degree 2. So that what you can do here, from an you can write. See here degree is 2 means you can write for an m power 2 or r power 2. For the second term you can write m power 1 or r power 1. Okay. For the third term you can write only constant. Okay, directly you can write. Actually this I have written here for understanding. No need to write this in the exam. Okay, you can write directly this. Okay, after this make use of calculator. You can find the roots. These two values. See m is equal to 3 or minus 2. M or r. You can say r also. No problem. So now this is called characteristic roots. Okay. Now we will go to the algorithm. Now you see here, if your two roots are distinct roots, how to write the general solution? This is the way. an alpha 1 r1 power n plus alpha 2 r2 power n. So now alpha 1 alpha 2 are constants. Now here I am using, see same idea. See an or ar, here an I can write. Okay, an I can write. No problem. An is equal to c1, any constant c1 minus 2 power n. Why? Because this first value. Okay, sorry, this value minus 2 power n. Then m is equal to 3. This 3 here, c2 second root power n. Okay, this is the way how to write a general solution, means complete solution. Now what we have to do? See what is given in the question. See here we have written the solution, but we have to find the value of c1 and c2. How to find c1 and c2? Now you see a naught equal to 3, a1 equal to 6 is given. So now you take the first value. A naught equal to 3. Okay, you substitute this. See, I have this equation. an is equal to c1 minus 2 power n plus c2 3 power n. Now you put this n is equal to 0 here. Okay, at n equal to 0, what is the value of an? That is 3. Okay, so if n is equal to 0, that is here 3. So now c1, this power 0 minus 2 power 0. So this minus 2 power 0, here 3 power 0 is equal to this value. See in this equation an, see put n equal to 0. So a0 is 3. So you can write here 3. Okay. Then you will get the equation. This minus 2 power 0 1, 3 power 0 1. So you will get c1 plus c2 is equal to 3. Similarly, take this equation. a1 is equal to 6. Okay. So you substitute here. N is equal to 1 and that value is 6. See this is 6. Right side value. Then put n is equal to 1 in this equation. Okay. Put n is equal to 1. See here this one. So now you will get minus 2 c1 plus 3 c2 equal to 6. Okay. What you do? You solve this equation and this equation. That is equation number 3 and 4 you solve for c1 c2. So you will get c1 equal to 3 over 5 and c2 is equal to 12 over 5. Okay. This you can solve in the calculator. Okay. Now finally I can write an is equal to 3 by 5, the c1, then minus 2 power n plus c2 12 over 5, 3 power n. This is the complete solution of the given recurrent solution. That's it. We will see the continuation of this in the next video. Thank you.